Welcome to the third part of the lecture series on the ultramicrotome. So we have discussed about the ultramicrotome, the various features of the ultramicrotome in the first lecture, and the second lecture we talked about the block trimming. So that means at the end of the second session, you know how to make a block available and then how to make the trimming and the shaping of the block in the once the block is ready. Now here we are going to discuss about the ultramicrotomy knife, the various features of the ultramicrotomy knife, specifically about the specimen arm, and then how to pick up the sections in this presentation. So now coming back to the knife, we have two options here. One is a diamond knife and the other one is a glass knife. So the diamond knife has a sharp diamond that is of like a gem quality diamond at one end and then followed by a trough here. So this trough is meant for storing the water so that the sections that are coming here will start floating and thereby help us to pick up the sections easily from the electron microscope grade. And coming back to the glass knife also has a sharp edge here. This sharp edge will be used as for just making the sections, and then there will be a small trough made arrangement here, and this trough will help us to store the water. And then the difference between the glass knife and the diamond knife is the diamond knife is commercially available, and this will be used for the more critical work or maybe publication quality work. And when do you use the glass knife? Glass knife is mostly used for screening purposes or rough measurements. So then first let us start with the glass knife, how to make the glass. For this we have to start with a square glass. Let me show you this. So this is the one, like let us assume that this is a square glass plate, and if you draw a line with a diamond cutter or the glass cutter along the diagonal of the square and just a small pressure in these two directions, holding it with a hand. If you just move this hand in two directions, what happens is the glass will be broken into two pieces. If you are not sure what exactly I'm talking about, just go back to some Hollywood movies and where the character, the let it be hero or villain, will be just breaking down the glass into two pieces with the help of a glass cutter. It will be like a very small handheld instrument, look like a pen, and what you have to do is you have to draw a line across it. This is what we call as a scaling. So once you draw a scale the line on the surface of the glass, and if you apply a little pressure in opposite directions, the glass exactly breaks into the linear part, and no more defects can be seen. So that is the property of the glass. The point slide. Yeah, here it is. So this is the glass knife that you can see the rectangular part, and then what we do is we use a tape here just round around to form an enclosure here. This enclosure is what we call as a trough, and this can be used to store the water here. Now if you look at it, the entire system, this diamond is replaced with the sharp edge of the glass here, and the trough is self-made here with the help of the tape. And to order like to prevent the leakage of the water, we just add some wax seal here so that one the tape will be firm. Second, it prevents the leakage of the water. So now the whole setup is just placed in front of the arm. Now the question arises, which one to use on what occasion? We have like two options here, the diamond knife and the glass knife. The diamond knife, as this word says, the diamond is of very expensive, and also we are calling this as a gem quality. So mostly the diamond knife is of expensive nature, and it is commercially available. You cannot make it in the laboratory, and this will be used only for the more critical analysis or more accurate analysis. For anything that is required like a rough screening, we go for glass knife. So what all required for the glass knife is only a piece of glass. Of course, the piece of the glass should also be well prepared. That has to also it has to be procured through commercial sources. But procuring the glass, even though through commercial sources, is much easier and cheaper than procuring a diamond. So that's why for all rough measurements or screening purposes, people will go for the glass knife, and for a more accurate one or publication quality work, people will go for the diamond knife. So apart from this, there is no much difference between the diamond knife, the functionality of the diamond knife and the glass knife. Both of them has a sharp edge which are capable of making the sections. Both of them has the trough here which are meant for storing the water, thereby you can let the sections floating. So as far as the function of these two knives are concerned, they are the same, and as far as the purpose of using them, they differ because of one, the quality, second, the cost of it. Now, can I just like the diamond knife, as I said, you can just place an order and just keep it in reserve and can use it when and where you want. But can that be done for the glass knife? In other words, can I make like 100 glass knives at once and then keep it aside and just start using it? That is not advisable for several reasons. One, the glass is known as a supercooled liquid. So if you are not known about this, just Google the word glass and supercooled liquid. You can see tons of pages coming out from the Google. So the take-home message here is that even though glass looks like a solid, it is considered as a supercooled liquid. So you know the liquid, the nature of the liquid is to start flowing. So even if you have a sharp edge when you make the glass cut, a freshly cut glass, but over time what happens is because of the slow fluid nature of the glass, the sharp edge becomes blunt. And once the glass becomes blunt, you know this is no longer useful for the glass knife. So that's why people prefer to have the glass knife made freshly cut from a glass piece before doing the experiment one. Second, a possibility of accumulation of dust here. So you may say that the possibility of accumulation of dust do present here as well, but this diamond knife will usually come with a case that where you can just minimize the dust, and if you want you can just prevent this, thereby you can minimize the presence of the dust accumulating at the tip of the glass knife, but still losing of the sharpness will pose you a greater threat or constraint for using the glass knife. So one, the take home message is if you want to go for a glass knife, just cut it just before doing the experiment so that you can make use of the best sharpness of the glass knife. So having said that, between the diamond knife and the glass knife, let's move on to the ultramicrotomy. So you know that the ultramicrotomy has a specimen arm and a knife. So this knife part we have just discussed about here, and what is left now is to discuss about the specimen arm. So the specimen arm will have the block trimmed specimen at one end, and the other end will be connected to some electrical circuits here. So when I say electrical circuits, I think you will be able to see the two connections here. So now what happens is, if you remember, this specimen arm is supposed to make a lateral movement and also a horizontal movement, so that the lateral movement will help us to make the sections and the horizontal movement will help us to control the thickness of the sections. So if you are not sure about this, go back and just look at the first presentation of this series, and there you can we have like a detailed discussions about this. Now this up and down movement can be used by with the help of a motor. Then how to make it advance? So this can be done actually, if you recollect, the speed with which it just makes the advance in the horizontal direction controls the thickness of the specimen. So if you want to have like a slow or thin sections, the specimen arm has to be moved in a slow direction. So that can be achieved by two means. One is a small electrical motor or the thermal feeder. So this is what we call as a feed. The feed help us to make a movement of the specimen arm in the horizontal direction towards the knife. So now what happens, now the feed can be obtained by either the electrical motor or the thermal effect. So what is the thermal effect means? Go back to your high school studies and you might have studied what is called thermal expansion. So what's a thermal expansion? A solid, whenever it is heated to a small temperature, there will be a increase in the length of it, and this is what we call as the thermal expansion. The increase of the length goes in 3 dimensions. If it is in 1 dimension, we call that as a linear. If it is in 2 dimensions, we call that areal expansion, and if it is in 3 dimension, we call it as a volume expansion. So we are not talking about all those the area and volume expansion. What we are concerned here is the linear expansion. So that means if you raise the specimen arm to a slightest temperature, the push or the expansion goes in this direction with that much distance, and by just controlling the temperature in a precise way, you can control the temperature, the direction in which it is expanding. So this is one arrangement that people will make. So that means now we have two arrangements: the up and down movement and the horizontal movement. Horizontal movement is achieved either by a thermal expansion or the motorized movement. So once we have the section start floating, then the question comes, since this arm, this is like a specimen arm here, and this is the trough here. So from this diagram, this is the part is just zoomed in and just shown here. Of course, phase inversion. The specimen arm is coming here, the knife is coming here. So now if you just correlate these two pictures, let's go on talking about what happens exactly here. So as this specimen arm makes a up and down movement, at the edge of the knife, the thin section of the specimen is cut separate, and that will be starts floating into the water. Now what we do here is these sections, as they start floating into the water, they look like a ribbon because this is in continuous movement, and this continuous movement, each strike will just make a thin section of it, and as it continuously moves up and down, you will see a thin section, the series of thin sections of layers coming out, and that is what we call as a ribbon of sections. So once this ribbon of sections starts floating, you just monitor them with the help of the binoculars, as you seen in the ultramicrotomy experiment. And once you are happy with the thickness of the sections that are coming out, then you can start collecting the sections using the grid. This grid, we have not discussed about this yet, and we are going to discuss about this in the coming slides. Okay, so this is all what happens once you make the knife. This knife has to be mounted here, and once the angle and the distance between the knife and the specimen arm are at the optimal levels, then you start making the movement of the arm, and this will help us to make the sections, and these sections are just collected here. Next question comes, what are the precautions to be followed when you are just working on it? The water here should be exactly at the optimal level of this, so it should not be overflowing, it should not be less, and there should not be any air bubbles on it. And as a precautionary measure, what is suggested is the first few sections that you are collecting has to be discarded. The reason why it has to be done so, because we put a lot of effort in here in just making a thin sections, and at the end you are saying we have to discard the first few sections. I'm saying discard only the first few sections, not all the sections. The first few sections are prone for having accumulating the contamination. The contamination may be coming from the edge of the knife or some of the contaminants that are floating into the water. So first of all, the water that you have to take here must be the doubly deionized water, so it has to be a purest form. So what we call as a millipore water, so it has to be a millipore water. And then, even despite of taking the millipore water here and preserving or freshly cut the knife here, there is a possibility of contamination, and in order to just make ourselves sure, we just discard the first few sections of the contamination. And once the sections are available here, take the grid with the help of a forceps, just make a contact with it, because of the surface tension between the grid and the sections that are coming. The sections automatically stick to the grid, and then you can take them off, so they will not just fall off, because remember, the thickness of the sections are going to be something like 50 nanometers or even less. So at that dimension, they will not have like a literally enough gravitational pull so that they can fall down, and the surface tension between the grids and the sections will dominate over the gravitational pull. So that means the grids can hold off the sections that you are seeing. Next question comes, what are the materials that can be used for the knife? So here is a scale of 10 to 1, 10 being the hardest material and 1 is being the softest material. And here all you can see the list of materials that are available for making the ultramicrotome knives. As you see, the diamond is in its first place, and somewhere here you can see the hard glass and also you can see the soft glass. The difference between hard glass and the soft glass are the composition. So you can Google about them and just find the difference between what is a hard glass and what is soft glass. But what we have discussed is the hard glass, also known as the quartz, is recommended for use of the ultramicrotome knife. So that's the end of the discussion on the ultramicrotome. Next session we'll start with a fresh topic. Thank you very much.